All right, we're going to introduce you to a growth formula. In actuality, you've already seen this growth formula because you've seen the compound interest formula, the PERT equation, the future interest, future quantity, future value, S is equal to PE to the RT. Okay? That was when we had compound interest, continuous compounded interest, okay? Which is, in short, exponential growth, okay? So whenever we're dealing with anything that is growing exponentially, okay, we're going to use that same formula, okay? Just assign it some different variables, all right? You'll see it down here, all right? The population is growing in from 1980 to 2000 by this quantity. We want to find a formula so we can make a prediction to the 2020 population. It is exponential growth. It is exponential growth. Our equation is an exponential growth equation. N, the future quantity, is equal to n sub 0. That's the initial quantity, times the Euler E to the power kt. Okay, it's the exact same formula. N equals n sub 0 e to the kt. Exponential growth. So another example, assuming exponential growth. Okay, population in 1990, population in 2000. What will be the population in 2010? Exponential growth. PERT equation, future quantity, the initial quantity, e to the power kt. K is a constant, the growth constant. It's a growth constant. It's a percentage rate, okay? All right, here it is. The formula is given to you, okay? In what time for the population to double? So that's, again, exponential growth. So let's refresh your memory with the problem that you are familiar with, continuous compounded interest, which is exponential growth, okay? Our equation, S equals, the future value is equal to the original amount, the original amount of principal, e to the power RT, okay? Since we want to triple, our new quantity is going to be 3p, is going to be p, e to the r, which we don't know, times the time. So we'll just put it as 21r, okay? So our ratio is 3, so we got 3 is equal to e to the 21r. Take the natural log of 3. Natural log of this side will just give us the 21r. So r would equal the natural log of 3 over 21, okay? Which we'll ask our calculator in terms of what that the actual decimal value should be, okay? So here we have it, okay? Turn the calculator on, clear it out. The natural log of 3 divided by 21, okay? Which gives us 0.0523, roughly 5.25%, so we're going to call it that. So our rate is going to be 5.25%, okay? All right, same exact formula. Future population is equal to the initial population times e to the power kt, okay? Our 1980 population, I don't care whether it's 1980, we're going to call it 1980 year 0. Year 0 has a population of 32,557, okay? 20 years later, year 20 has a population of 40,211. Feed that information into the exponential growth formula, n equals n sub 0 e to the kt, and predict the population 40 years from the original. So that's what we're after. Okay, so here we go. All right, here's the working equation. The original population of 32,557 grew exponentially by some rate over 20 years to a new population of 40,211. Equation is solvable by taking the log of both sides, but let's first divide by the coefficient 32,000 here. So we get e to the 20r is equal to 40,211 over 32,557. We're going to take natural log of both sides. Natural log here would just give us 20r, and that would be the natural log of that quantity, 40,211 over 32,557. Let's do the number crunching on that right now. Divide that by 20 to find out the rate. Having the rate, we'll come back and use it for predictive purposes. Let's pull up the calculator now. Okay, clear. Take the natural log of that 40,211 divided by 32,557. Okay, that's some value. Divide that by 20. Divide it by 20 because we want R. Looks like R is 0.010557, 0.0105. Round it off, 0.0106. Okay, so R is equal to 0.0106. Now, okay, now let's find our population in the year 2020. Okay, 0.0106 is our growth constant. All right, so okay, here we go. We've got a population, the initial population of 32,557 grew exponentially e to this constant value of 0.0106 over 40 years and becomes the new population. So what is it? You can only ask our calculator. Okay, so let's pull the calculator over here and clear it out. It's 32,557 times e to the power point. And tell you what we could do here is we could just come up and grab that power right there. So we take all the decimal places times 40, okay? And that should be our future population. 49,664. 49,664. We don't get a fractional part of an individual. We just truncate that. 49,664. 49,664 is the 2020 population. 49,664. Let's do another example, and just to show you again exactly how this works. Okay, same thing. 1990 year zero population is 28,432. 28,432. The year 2000, 10 years later, year 10 population is 30,211. What would be the population in 2010? So 20 years from the original day. Okay, so again, our population of 28,432 grew exponentially by some constant over 10 years and turned into 30,211. Divide by the coefficient. E to the 10k is going to equal 3211 over 28,432. So we're going to take the log, divide it by 10. So k is going to be 1/10 of the natural log of 3211 over 28,432. 28,432. Okay, then we'll see what that constant is. Then we'll throw it in the second time around and predict our future population. So let's pull up our calculator, okay, and clear it. We've got to take the the natural log of this quotient, 30,000 to 11 divided by 28,432, 28,432. Okay, and we're going to take 1/10 of that. It's just going to move the decimal place, divided by 10, right? So our growth constant is 0.00606, okay? So I tell you what, I'm not even going to write that down, because I'm going to come and I'm going to put that right back in the second time around. And what's the second time around? Okay, well, the second time around is to use that initial population, 28,432, e to the 10k, well, in this case, it's going to be 20k, and that's my value of k. So that'd be our future population. Let's do it, okay? So here we go. It's going to be 28,432, 432, okay, times e to that constant. Just go up and grab it, times 20, right? Times 20. So our 2010 population is 32,000. What is that? 32,101. Okay, equals 32,101 individuals in the year 2010. So that is exponential growth using the exponential growth equation. The future quantity is the initial quantity, e to the growth constant times time. N, future quantity, is equal to the initial quantity, n sub 0, times e to the power growth constant times time. N equals n sub 0 e to the kt. That is your exponential growth right there.